Okay, we were on question number 7. We were in the midst of finding our WO because they had given us a threshold wavelength. We found our threshold frequency, and now we were using it to find our work function. And so while the last video was uploading, I found it to be 3.42484 times 10 to the negative 19 joules. So this is my WO. In the end, in the question, we are looking for the color of the light, the frequency of the wavelength of the photon. But to find that, I first need to find the frequency of the photon, which means I'm going to need to use the photoelectric effect equation. So I got my WO in the photoelectric effect equation, and now I'm about to use my de Broglie wavelength for my electron to find the velocity of my electron. So we know from de Broglie's wave equation that the wavelength of the electron is equal to h over mv, which means v is equal to h over m times the wavelength. H is 6.626 times 10 to the negative 34 joule seconds. It's an electron, so its mass is 9.109 times 10 to the negative 31 kilograms, and the wavelength they gave us to be 1.561 nanometers, so times 10 to the negative 9 meters. Okay, so when you do this, you should get a speed for this electron to be 4.6599 times 10 to the 5th meters per second. Okay, now we can use the speed of the electron to find its kinetic energy, because we know EK max is simply equal to 1/2 mv squared. So 1/2 mass of the electron, again, 9.109 times 10 to the negative 31 kilograms, and then the speed we just found, 4.6599 times 10 to the 5th meters per second, and don't forget to square it. So you get an EK max of 9.89 times 10 to the negative 20 joules. So I have my EK max, I have my WO. I can now go to my photoelectric effect equation. EK max is equal to HF minus WO, and I can rearrange for HF. So HF will equal EK max minus WO, right? I'm going to bring my I take that back, plus my WO, because I'm going to bring my WO over. So HF is equal to my EK max, 9.89 times 10 to the negative 20 joules. My WO was 3.424, so this is plus 3.42484 to the negative 19 joules. So I left it as HF here just because this is going to be the energy of the photon in case I need it later. 4.4138 times 10 to the negative 19 joules, but I really want F, so divide both sides by H. So F will equal 4.4138 times 10 to the negative 19 joules divided by 6.626 to the negative 34 joule seconds. F is equal to 6.6614 times 10 to the 14th hertz. Once I have this is the frequency of the light. I can now find the wavelength with C equals F lambda. So lambda is equal to C divided by F. So C is 2.9979 times 10 to the 8th meters per second, and F is the 6.6614 to the 14th that we just found, and you end up with a wavelength of 4.50 times 10 to the negative 7 meters, which you then need to look up in our little wavelength chart, and when you do, you find out that it's blue. Okay? All right, so hopefully photoelectric effect and a photoelectric effect with de Broglie's wavelength, hopefully they're getting better.